Hello students, today we are going to learn the transpose of a matrix, and with the help of transpose of matrix we will study the two special type of matrices, symmetric and skew symmetric matrices. So let us start. What is the transpose of a matrix? Now if a matrix whose element is represented by a ij, where I is row and j is column, this is a matrix of order m by n. If there are total m rows and n columns, then we can obtain another matrix by interchanging the rows and columns of A. That matrix is known as transpose of a matrix. So, the transpose of a matrix can be obtained by the interchanging of rows and columns of a matrix. This matrix is represented by A prime or A raised to the power t transpose of A. Now we can represent that if A equals to Aij of order m by n, then the transpose of that matrix A prime is equals to Aj n cross n. Means the rows and columns are interchanged. So number of rows becomes the number of columns, and number of columns interchanged to number of rows. So order is also reversed here. Now one example is here. If matrix A is equals to, the elements of first row are 3, 5, 7, elements of second row are 2, 9, 4. This matrix is of order 2 by 3. Now the transpose of this matrix will be, the first row was 3, 5, 7, so it will become 3, 5, 7 first column, and second row we have like second column 2, 9, 4. You can see this is the first row. Now this first row becomes the first column, and this is the second row. Now this second row becomes the second column. So order is changed. The order of matrix A was 2 by 3. Now the order of transpose of matrix A is 3 by 2. So order is also interchanged. Now some properties of transpose of a matrix. Transpose of a transpose matrix means if we find the transpose of a transpose matrix, then we will get the same matrix once again. We can see with the help of this example, matrix A is 2, 3, 5, 7. The transpose of this matrix is, this is the first row, so it will be here in the first column. The second row, it will be here in second column. So this is the transpose of transpose of matrix A. Now if we find the transpose of this matrix once again, then again change the rows and columns, interchange. The first row is here 2, 5, so it will be the first column. The second row 3, 7, it will be the second column. Now you can check that the transpose of matrix is same as the matrix. All the elements, all the corresponding elements are same. It means this, the transpose of a matrix is again the same matrix. The second property is, if a matrix is multiplied by a constant and then transpose it, so it is equals to transpose of the matrix multiplied by k, means that constant. Sorry for the disturbance. Yes. So if we multiply any matrix by a constant k and then transpose it, it is always equal to the transpose of that matrix when multiplied by that constant. So we can prove this also very easily by taking one example. Let us taking the same example A. If we are multiplying by this by k, then we get matrix 2k, 3k, 5k and 7k. And if we take the transpose of this matrix, then it will be 2k, 5k, this is the 3k and 7k. The matrix when multiplied by k and taking transpose of this, now see the transpose of that matrix is here when it multiplied by k, that is k times of transpose of that matrix is 2, 5, 3, 7. So it is 2 times of k, 5 times of k, 3 times of k, 7 times of k. You can see these are same, the result is same. So when a matrix multiplied by a constant and we are taking the transpose, or we transpose the matrix then multiplied by k, in both cases the result is same. Now the third property is if you are taking sum of two matrices and then transpose it, or if we transpose the two different matrices and then add them, the result is same. We can also obtain this by taking any two examples. And the fourth property is the transpose of product of two matrices A and B is equals to the product of transpose of these two matrices, but order is interchanged. If we are taking here transpose of AB, then we have to take B first, A prime. And if we are taking here BA, transpose of B into A, then here it is A prime, B prime. We shall discuss this later in some examples. Now we are moving forward. The symmetric matrix. What is the symmetric matrix? A square matrix. The first condition is symmetric matrix is always a square matrix. A square matrix A, whose element is represented by Aij, is said to be symmetric if transpose of that matrix is equals to the given matrix. Means if in a square matrix the transpose of the matrix is equal to the given matrix, that matrix is known as symmetric matrix. So it means the row and columns are interchanged. After interchanging the row and columns, we are obtaining transpose of the matrix, and transpose of matrix is same as the given matrix. It means Aij, that matrix is equals to Aj for all possible values of I and j. We are taking one example to understand this. Let a matrix A here. The elements of A are 5, 2, 3 in the first row, in second row 2, 7, minus 1, in third row 3, minus 1, 8. Now this is a symmetric matrix. How it is symmetric? So we can check by obtaining the transpose of this matrix. In the transpose, the first row behaves like the first column. So here first row is 5, 2, 3. So write these elements in first column. Now the second row is 2, 7, minus 1. So write this in second column 2, 7, minus 1. Now third row is 3, minus 1, 8. So it will be in the third column. This is the transpose of this matrix. Now check what is the difference between these two matrices. Both are same. Now after transposing, the first row elements are 5, 2, 3. Here also 5, 2, 3. Second row elements are 2, 7, minus 1. Here also these are 2, 7, minus 1. Now the elements of third row are 3, minus 1, 8. Here also these are 3, minus 1, 8. It means the transpose of the matrix is equals to the given matrix. So this is an example of symmetric matrix. These type of matrices are called symmetric matrix. Now the next one is skew-symmetric matrix. It is also a square matrix. A square matrix A, elements represented by a ij, is said to be skew-symmetric matrix if the transpose of that matrix is equals to negative of that matrix, means if that matrix is multiplied by minus 1, or after changing the sign of all the elements. Okay, that is Aj is equals to minus Aij. We are interchanging rows and columns, then the sign of elements is interchanged. If a positive element is given, then it becomes negative. If negative element is given, then it becomes positive. So it is for all possible values of I and j. Now, if we put I equal to j here, means we are putting I in place of j also, because I and j are equal. Then we get aii is equals to minus aij, that was minus aii, because j equals to I. So it implies that 2 times of aii equals to 0, and what is the value of aii? That is also 0 for all i's. Aii means row and column if both represent the same number, means either the element of first row and first column, element of second row and second column, element of third row and third column, and these elements are called diagonal elements. It means all the diagonal elements of a skew-symmetric matrix are 0. So remember this thing, it is a very important fact. The diagonal elements of a skew-symmetric matrix are always 0. Now one example is here. The first row is 0, 3, 7, minus 3, 0, 5, second row, and third row is minus 7, minus 5, 0. Here, the transpose of this matrix is equals to minus 1 into that given matrix. Now, you can check it. First of all, we are going to obtain the transpose of this matrix, means we are interchanging the row and column. So first row 0, 3, 7, so it will be here in first column. Second row is minus 305, so minus 305 it is second column. Minus 7, minus 50 it is third row, so it becomes the third column. So this is the transpose of this matrix. Now if we are multiplying or changing the sign of all the elements of that matrix, 0 with negative sign, that is 0, 3 with negative sign, 7 with negative sign. Now minus 3, it was already negative, so by taking negative sign it will be positive. 0, minus 5, 7, 5 and 0. Now check both of these. Both are same. So the given matrix A is a skew-symmetric matrix, because here the transpose of that matrix is equal to the negative of that matrix. So this is an example of skew-symmetric matrix. Now some results. The first result is for any square matrix A with real number entries, if any square matrix is given with real entries, real number entries, then the sum of that matrix and its symmetric matrix, well, it's a transpose, that is A plus transpose of A is a symmetric matrix. If we are adding a matrix with the transpose of that matrix, then we get a symmetric matrix. Another one is, if we are taking difference A minus A prime, means from the matrix, if we are subtracting transpose of this, then we are getting a skew symmetric matrix. Now, with the help of one example, we can check this property. Taking a matrix A, that is 1, 5, 6, 7. We are going to check, or we are going to verify that A plus transpose A is symmetric and A minus A prime is skew symmetric. So, in both cases, first of all, we have to find transpose of A. So, what is the transpose of A? Change the row and column, interchange. First row will become first column, second row, second column. This is transpose of A. Now obtain the sum. One, 5, 6, 7, and adding 1, 6, 5, 7. So it will be 1 plus 1, 5 plus 6, 6 plus 5, 7 plus 7. So it will be 2, 11, 11, 14. Now you can observe that this matrix is symmetric because if we obtain the transpose of this matrix, then we get the same matrix. So here you can see that A plus A prime transpose is equals to A plus A prime. It means sum of a matrix with its transpose is always a symmetric matrix. It is verified. Now we are going to verify the second one, that A minus A prime is a skew symmetric. Now A minus A prime, that is, what are the values in A? These are 1, 5, 6, 7, 1, 5, 6, 7, and its transpose is 1, 6, 5, 7. So it is 1 minus 1, 5 minus 6, 6 minus 5, 7 minus 7. We are getting 0, minus 1, 1, 0. So here A minus A prime is a skew symmetric. We can check if we are taking the transpose of this matrix, then we are getting 0, minus 1, 1, 0. And if we are multiplying by minus 1 to this matrix, this one, then we are getting the same matrix. It means the transpose of difference of a matrix with the transpose of that matrix is equal to negative of The difference of these two matrices means that matrix and transpose of that matrix. Now the second result is any square matrix can be expressed as the sum of symmetric and skew-symmetric matrix. If any square matrix is given, then it can be expressed as the sum of symmetric and skew-symmetric matrix. So easily we can understand this, like if you are taking a matrix A, it is equals to 1 by 2 A plus A prime plus 1 upon 2 A minus A prime. Here in the first result we have already observed that a square matrix added with the transpose of its, then we get a symmetric matrix. If we subtract a transpose of a matrix from the given matrix, then we get a skew-symmetric matrix. Now, if we are adding these two, then positive A prime, negative A prime cancel out. 1 upon 2 times of A, 1 upon 2 times A, that is equals to A. We are getting the same matrix. So any matrix can be written, any square matrix can be written in the form of, or in the as the sum of, it can be expressed as the sum of symmetric and skew-symmetric matrices. Now we are taking one problem related to this. If A is equals to cos alpha sin alpha minus sin alpha and cos alpha, then verify that A prime A is equals to identity element. So here we have to multiply matrix with its transpose. So first of all, we will find the transpose of the matrix. Its transpose will be cos alpha sin alpha minus sin alpha cos. Here the first row was cos alpha sin alpha, so it becomes the first column, and second row minus sin alpha cos alpha, it becomes the second column. Now multiply. We know that the product of matrices is not commutative, so do not change the order. Whatever given in the question, take the same order. So A prime into A is here, so we are taking A prime into A. Cos alpha minus sin alpha cos alpha, this is the transpose. Now multiplying with the matrix cos alpha sin alpha minus sin alpha and cos alpha. Now we have already learned how to multiply two matrices. First row multiplying with first column, that is cos alpha into cos alpha minus sin alpha with minus sin alpha. Now for the second element of first row, we are multiplying first row with second column. So cos alpha into sin alpha plus minus sin alpha into cos alpha. For the element of second row first column, we are multiplying second row with first column, sin alpha into cos alpha plus cos alpha multiplying with minus sin alpha, and finally the second row multiplying with second column, we are getting sin alpha into sin alpha plus cos alpha into cos alpha. Now simplify cos alpha into cos alpha, that is cos square alpha, minus minus plus, that is sin alpha into sin alpha is sin square alpha. It is sin alpha into cos alpha minus sin alpha into cos alpha. It is sin alpha into cos alpha minus sin alpha into cos alpha, and here it is sin square alpha plus cos square alpha. Now using the first identity of trigonometry, sin square alpha plus cos square alpha is 1. Here sin alpha cos alpha is positive, sin alpha cos alpha negative, so these are cancel out. Here also sin alpha cos alpha is negative, and this one is positive, so cancel out 0. And here using the first identity of trigonometry, it is 1. And what is this? This is identity matrix which was to be proved. So here the A prime into A is equals to the identity element. Now taking another question, that this is the multiple choice question. If there is a matrix A, elements are cos alpha minus sin alpha and cos alpha, then A plus A prime is equals to I if the value of alpha is, option A is pi by 6, option B is pi by 3, option C is pi, and option D is 3 pi by 2. You see the solution? Here the sum of matrix and its transpose is given equals to identity. So first of all find the transpose of given matrix. So first row is given cos alpha minus sin alpha. So cos alpha minus sin alpha, it will be the second first column. Now the second row, it was sin alpha cos alpha, it will be the second column because in the transpose the row and columns are interchanged. This is A prime. Now in the question it is given A plus A prime equals to I. So place the value. Matrix A was cos alpha minus sin alpha, cos alpha, and A prime is cos alpha sin alpha minus sin alpha cos alpha. It is equals to 1001. Now find the sum of these two matrices. So we are getting cos alpha plus cos alpha minus sin alpha plus sin alpha, sin alpha minus sin alpha, and cos alpha plus cos alpha is equals to 1001. Here minus sin alpha plus sin alpha cancel out, here also cancel out. So we are getting 2 cos alpha 0 0 2 cos alpha, it is equals to 1001. Now compare. So 2 cos alpha is equals to 1, means cos alpha is equals to 1 by 2. So alpha is equals to cos inverse 1 by 2, and you know very well that it is equals to pi by 3. We have already studied in the previous chapter inverse trigonometric function. to find the value. So the value of alpha is pi by 3. So which option is correct? Option B. Option B is correct. It is pi by 3. Okay. Now we have covered other things. One thing is remaining, that using the elementary transformation or elementary operation method to find the invertible matrix or inverse of the matrix. So we will take that one in the next lecture. Thank you.